Here you go, Brian. First set of notes for the fourth 9 weeks. Write this down. We will take the test on Tuesday.
Wait, question.
Yes.
This is chapter 6 review.
Chapter 6 review.
Peyton, it says chapter 6 review.
I see that for firemen.
Peyton's getting ready to ask because
I want to keep it in order now.
Peyton, your circus.
I have no idea.
I shall not be here on Tuesday.
I know you should take it today.
Oh, geez, Wesley.
I can't.
Yeah, I bet
I
you could.
have.
He just is like,
I need
why?
a whole weekend to study, Mr. Eversole.
So come in Monday during intervention, take it.
I won't be here Monday.
Come in Wednesday during intervention.
You won't be
take
here
it.
Wednesday either.
What's this number?
He's gonna be sick on Wednesday.
Yeah, just do what he did to me.
I'll
Press
be
zero
alright.
on it so he actually comes in and
If you won't be here on Wednesday,
No,
then
I'll be here Wednesday.
then I'll just make the easy grade. Put that grade
I
on
won't be
there.
happy. My mom won't be happy either.
Don't worry.
Well, man, you
That's
can get
my
the
job
call
is to
from her.
make people happy.
Yeah, my mom will call you.
You wouldn't get like a call, like a normal
In Weston's
call.
house,
You would get it from an
Mr. Eversole doesn't call
ETM,
you.
like,
So if, because a lot of you with your binders, if you do write them somewhere else, I don't have a problem with that. But if you got one spiral thing that you put them all, or that you put them in, then do that every day so that you know where they're at and they're in some kind of order. Then you can just transfer them over. That's fine. There ain't nothing wrong with doing that.
That's where mine are. I still always get bad grades in my binders.
But if you put them in one spiral, then another spiral, then another one, and you can't find them all at the end, then you're out of luck.
You lose
Josh,
stuff.
Right on this, set up ratios and proportions, and I'll just, some of these I won't write a whole lot with, some of them I'll write a little more with, and we'll add some stuff. When you're setting up ratios and proportions, be able to set up, not just with triangles, but with any real life thing. I know that we had some problems that said something like, Farmer Brown has 5 apples and 10 cherries. And they wanted you to write a ratio for that. Make sure you write it in the order that they want it, because if it says compare apples to cherries, then it'd be 5/10. But if it says compare cherries to apples, then it'd be 10/5. And make sure you reduce those down. And just like Josh just said, if you reduce it down, just like with scale factor, you still need that 1 underneath there. And it might be, remember, it could be written with the colon in it. Oops.
I like doing that better. More than once.
The colon's actually a better mathematical
The
way.
ratio thing, I do that, but then when I'm doing like proportion.
Right. This is probably a better mathematical way to write it. This is, with the fraction, is easier to do the math if we have to do any math with it. Be able to identify similar polygons. The ones that we dealt with the most were triangles. And what's the easiest way to tell if 2 triangles are similar? What's the easiest way to prove it?
Angle.
Angle. All right, that's the one we use most of the time when we drew all those pictures with the shadows and the mirrors and everything else. We didn't even think about it anymore, because every time if you have 2 shadows, what do you know about the 2 triangles that are formed? They're similar to each other. So we didn't even think about it anymore, even though this angle right here has to be congruent to this one. This angle has to be congruent to this one. But we just knew, hey, if it's one of the shadow problems, those 2 triangles are going to be similar to each other. But be able to identify the similar polygons, whether they're triangles, rectangles, whatever. In similar triangles, I should have wrote this word in here. What do you know about the angles in similar figures, any polygons? The angles are congruent, and I should have written corresponding angles. So make sure you know corresponding angles are congruent. The angles that match up have to be congruent. About corresponding sides, what do they have to be? Proportional. Guarantee there's a few problems on the test about these corresponding angles. If I give you two triangles and I tell you they're similar to each other and I tell you this angle right here is 50 degrees, what do you know about that angle over there then?
Well, maybe it's on its side.
It's got to be 50 degrees. All right? Make sure, and Josh is right, make sure you match them up correctly. You can match them up. If I tell you triangle ABC is similar to triangle QRS, then angle A has to match up to what angle in the other one? Q. Angle B has to match up to angle R, and C has to match up to angle S. So make sure you match those up. With scale factor, remember with scale factor, you just match up any two corresponding sides. And then the big thing with scale factor, I think most of you can find the scale factor of any of the shapes, but then the big thing is you got to do what after you match them up? What do you got to do to that fraction? Reduce it. Make sure you reduce it. Remember, scale factor also goes along with the perimeter ratio. I didn't put anything about perimeter ratio on there, but when we get down here to the theorems, there are problems on there about the theorems that deal with the perimeters. We'll talk about that. Why do you think I put all these asterisks here beside this?
Probably need it.
That's what we did most all the time, set up proportions and solve them. The whole chapter, probably 90% of the problems on the test, setting up two ratios equal to each other, setting up the whole proportion, cross multiplying and solving.
I don't know how to set up a portion.
You know, then you'll be, then we ought to take the test today because it won't matter if we take it next
You're gonna see
week
Mr.
or.
Eversole next year.
You're still leaving, David.
No,
What?
no, he wouldn't because his mom and dad would kill him if he didn't pass my
If I-
class.
yeah, I wouldn't be here no matter what. I'm not gonna be here no matter what. 'Cause either I'm gonna pass or I'm gonna be dead.
It's just,
That wouldn't work. It'd be the same with one of my sons. You what? Didn't pass the math, OGT? What?
alright, you're getting 5 across the
All right. Using the theorems to set up proportions, I'm going to erase some of this. On these theorems, you can add this in anywhere. I don't have room up here since I'm trying to write it on the board here. But so on this, different theorems that we talked about. One of them was that theorem we just got done talking about a few minutes ago. If these two are parallel to each other, you could split the two triangles off and set up the proportions. But if you know that part's A, this is B, this is C, this is D, if you know the four parts and those two lines are parallel, then what proportion can we set up?
A, B,
A over B,
C, D.
C over D. You can just set it up that way without splitting off the triangles. Now sometimes, again, they'll tell you, maybe they tell you this whole side. Maybe they tell you the whole thing is, I think one of the problems that we just did, the whole thing was 33 and this part up here was 11. Well, could we find this part? Yeah, you just subtract those two and it gave you that. And then you could set up that proportion. So that's one of them that we did. Another theorem that we had, I know there's a couple of problems on there about this theorem. What's happening to that angle right there?
It's getting bisected.
It's getting bisected. We had a theorem, the triangles aren't similar to each other, but we had a theorem that, and I'll put in some different letters here, let's do X, Y, Z, and W. We had a theorem that said if this angle is being bisected, or if an angle in a triangle is being bisected, then you can set up a proportion. Does anybody remember what it would be for this one? Guess at least one of the letters. You can at least pull
X.
X, thank you. X matches up to, you can do it two different
Y.
ways. X matches up to Y, so this matches up to this. The same as Z matches up to W. If it's an angle bisector, if you have an angle that's being bisected, then you can set up that proportion. And Peyton said you could match it X up to Z. Well, if you match X up to Z,
Y to W.
then Y to W. Either one of those proportions would work. Perimeter theorem. If I give you two triangles, and I tell you these two triangles are similar, I tell you the perimeter of this one is 12, I'm just making up numbers. This side right here is 4, this side is 8. Could you find the perimeter of this one? Do you have to find all the sides separately? No, you just set up the proportion you set up. You match up the two sides, side from the first triangle, side from the second triangle, any of the corresponding sides, which in this case would be 4 and 8. And then perimeter of the first triangle compared to perimeter of the second triangle. As we were doing those worksheets yesterday in my classes, I walked around watching people, and they were finding the other sides. You could find the other sides and add them all up, and that would still give you the perimeter. But if you do it this way, then you only have to solve one proportion instead of two. And it makes it a little easier. So remember that the perimeters are at the same ratio to each other as any pair of corresponding sides. Then the next theorem was the mid-segment theorem. I'm going to jump down here to the mid-segment. Mid-segment theorem. Remember, to be a mid-segment, what has to be true about that point right there?
Middle.
It's the midpoint, so those two have to be congruent. What has to be true about that one? Midpoint, those two have to be congruent. Doesn't mean all four of them have to be congruent, but these two have to be and these two have to be. With the mid-segment, what's the mid-segment theorem say? What do you know about
It is half the length of the
Base.
mid-segment is half the, I'm not going to say the base because could they turn that triangle around on you and try to confuse you?
no.
They could.
Yes.
They could.
So I can draw this and put the mid-segment coming down through here. That's true, but now, if we look at that, is this the base anymore? Doesn't look like the base to most of you because you usually think of the base as being on the bottom. Alright, so mid-segment is half the third side, or the side that it's parallel to, if that helps you. Can't draw parallel. Parallel. Side that it's parallel to. So if I told you this side down here was 30, how long is that mid-segment?
15.
15. If I told you that mid-segment was 4, how long is that third side? 8. So on and so on. And then the last thing, indirect measurement. All I'm going to write about indirect measurement. What kind of problems did we do with indirect measurement? Shadow and what was the other one? Used a what? A mirror. Shadow and mirror problems. Oh, one other thing I wanted to add on to this. Add this down at the bottom of your notes or something. What if I give you let's say first are the angles of a triangle.
Okay.
What do you got to remember to do as soon as you see that you have something like 3:4:5? You could draw the triangle. Does that mean this angle's 3? It's 3x. What do you do as soon as you see that? Put,
Then equal to each other equal 180.
but first you got to put a what with each one?
X.
Variable.
Put a variable with each.
Preferably X.
I prefer Y.
With
Competition.
W.
So make sure, because I know there's a couple of problems on the test, make sure you remember that. Now these, since they're the angles, they have to add up to be how much? 180. Is that always the case? What if I told you the sides were at 5, 6, and 3.
No, but you said you said them to the angles.
Instead of angles, they.
Angles are 180,
I'm
right?
talking about angles right now.
These are angles, so these have to add up to be 180. That's what you
The
said.
sides, they just have to.
The sides have to add up to be the what? Whatever the perimeter is. All right. So, but make sure it's not 5, 3, and 6. You got to stick that variable with each one.
Still?
If they give it to you this way, if they give you this, they say the sides are at a ratio of 5 to 3 to 6. So if the problem starts off with something like this, then you got to put a variable with each one. Now I have this bad feeling now I'm going to confuse somebody, because if they give you a triangle and they tell you this is 7, this is 8, this is 10,
Yeah.
if you put a variable with each one of those, no, that's just saying that that triangle is that. If it starts off this way,
Yeah.
then you got to put a variable with each one. Sorry, I didn't want to write out 60,000 different things there as I was explaining it. End up doing it anyway. I should have just done it from the beginning. Make sure I've talked about everything. Oh, word problems. Some word problems. Again, this goes back to the real life stuff. Just because we've been dealing with triangles all the time, does that mean you can't set up proportions with other things? Let's say Farmer John expects that an apple tree will produce 5 apples, while an orange tree will produce 3 oranges in the same amount of time. And if he has 10 apple trees,
5 orange.
and you wanted to figure out how many apples he's going to expect to get, could you set up a proportion on that? Yeah. And now this is a real simple one, and you
5
probably,
is a 10 or
you,
you're
you
right.
probably wouldn't have to, all right? If you figure out one tree compared to 5 apples, then 10 trees is going to be 2x apples, and you could cross multiply. And that doesn't just, I'm making up some stupid one, but that works for anything. The one I know is on the test says something about some factory making whatever. All right? Maybe they make boxes, and they know out of every 100 boxes they make, 2 of them are messed up. They have to throw them out. And they say, all right, so Faith goes to work in the factory, and she's there working, and she puts out 10,000 boxes a day. How many of those should she expect are going to be bad boxes? Well, since it's Faith, we'd say 0, because we know she's perfect, right?
If it's bright in there, it's taking like 7.
If it's Brighton, then we
Each
estimate
hour.
5 maybe. But does everybody see what I'm saying? You can set up a proportion to find how many are actually going to be bad. And factories actually do that. They say, all right, Emma's working there, and Faith's working there. They're both working there, and one of them works second shift, one of them works third. Emma's putting out her boxes, and 3 out of every 10,000 are bad. Faith's putting out her boxes, and 20 out of every 10,000 are bad. After a while, they're going to start thinking, what in the world's Faith doing? She's not doing her job very well. She's over there talking on the phone or something else while the boxes are running through, not paying any attention. Right? So they do that to make sure that your quality of production stays where it should be. I know I had my